Okay, so let me check if we are live or not so that I can start the class. Okay, so just give me a moment. Okay. Okay. So hey everyone, hi, hello, good evening. Welcome to Unacademy ICSE and ISC YouTube channel. So this is Manisha, your class 10 chemistry educator. I have 6 years of teaching experience. These are my credentials. Today we are going to have a power pack revision on your metallurgy chapter. Okay. So before that, you can join me on Telegram using this link where you will be getting your class notes and homework in PDF format. We also have an official Telegram channel of your Unacademy ICS and ISC boards where you will be getting all the important notifications, your class links and everything you will be getting on this channel. So the link of this channel is given in the description box, which you can click and join. So if you want, you can join me on Unacademy free special classes also. Hello, great suggestion. Welcome to the session. So you can have a real-time interaction using chat and emojis with me. You can ask questions using the question tab. You can have live poll options for the quiz, poll leaderboard. You can compete with your friends. Too many things to do on Unacademy special classes. These classes are absolutely for free. You don't have to do anything. You have to just download the Unacademy app. You follow all the instructions, whatever means information you have been asked. Please provide that information. Then use my code Manisha Live and you will be getting every class unlocked and you can watch my free special classes. Okay. So special class timetable for class 10. So today we had a power pack revision on hydrogen chloride and 10th ko we will be having your power pack revision on preparation of ammonia. So special classes for class 10 start at 4 p.m. and ends at 5. So you can join me over there also. So before I start the class, let me tell you the features of Unacademy Plus subscription if in case you are interested in taking that. So you can learn live from the comfort of your home. You can have unlimited access to all the courses. Top educators of India teaching on this platform, regular doubt clearing sessions, exhaustive coverage of syllabus, mentorship and guidance, study material, practice test, everything you will be getting on this particular platform with the single subscription. And if you take Unacademy Plus subscription for class 10, you get 11 and 12 subscription for absolutely free. Manisha Live is the code which will give you 10% discount. So you have to use this code and get the 10% discount. So you can go for 12 month subscription if you want to, so that it can help you in your future classes also. Okay. So if you want to just prepare for your boards, so do not worry. You can have like 3 month subscription where you will be getting 10% off on the 3 month subscription price. So use my code Manisha Live and this is only valid for the first 500 subscribers. And if you take like means if you take the subscription for 12 months, you get 1 month extension. Okay, so in the price of 12 months, you get 13 months subscription. So that is also a great deal. So before I start the class, so please let me know if I am clearly visible and audible to everyone in the class. Yes? Am I clearly visible and audible to everyone in the class? Okay. So just start the, so let's start the class. So metallurgy we had starting today. So first of all, we'll start with the occurrence of metals. Okay. So where your basically your ores are found. So first of all, let's understand what are ores. Okay. Okay. Thank you. Great suggestion. So what are ores basically? Okay. So ores are the minerals. Okay. Basically ores are the minerals from which, okay, from which we can extract metals. Okay. We can extract metals. Number one, profitably. Number two, easily. Okay. Profitably. So just let me write that. Okay, Akash. So let's write it over here. So first of all, you must be able to extract the metals from the minerals profitably, and second is your easily. Okay, if you are able to extract the metals very conveniently and very profitably, then that minerals will be termed as ores. Okay, that minerals are termed as ores. So basically, what is mineral? If I ask you like what is mineral? Okay, so minerals are nothing but they are naturally occurring compounds. Okay, they are naturally occurring compounds which contain metals along with your some impurities. Okay, which contain metals along with some impurities. Now, can we extract metals from every mineral? Yes or no? Please let me know in the comment section. Can we extract metals from every minerals? So, as I told you, minerals are the naturally occurring compounds which are found inside the earth's crust. Okay, where these minerals are found? They are found inside the earth's crust, and these are naturally occurring compounds which contain metals along with your some impurities. Okay, so now what are ores? So those minerals are termed as ores from which we can extract metals, first of all profitably, second easily. Okay, so can we extract metals from every mineral? No, the answer is no. We can extract minerals from those ores which contain a very high amount, or you can say high concentration of a particular metal. Okay, so you can extract metals from those ores which contain very high amount of a particular metal, and that metal can be extracted easily and profitably from it. So minerals from which your metals can be extracted cheaply and easily are called ores. Okay, so there are 5 main steps where you have to means using those 5 steps you can extract your metals from the ores. Okay, that is your metallurgy. So basically metallurgy is the process where you can extract your metal from some minerals. Why we are calling some minerals? As you all know, we cannot extract metals from every mineral. Okay, we can extract metals from some of the minerals from which your metal can be extracted easily. So the process, the entire process which involves the extraction of metals from the ores step by step, that entire process is known by metallurgy. Okay, so metallurgy is not a very simple term that if you are studying class 10 processes and with those you can extract metals from ores. No, it's a very huge means you can say it's a very huge process, very costly process. That's why it is forming the economy of the country. Yeah, because everything, if you see around yourself, everything consists of metal only. Yeah, more or less everything is made up of metals only. Everywhere you see your electronics items, your cars, your food means utensils, your all means in your house, everything is made up of metals. So the process where this means the processes which involve the extraction of metals from the ore is your metallurgy. So 5 main steps. Okay, 5 main steps are involved in the extraction of metals from ores. Okay, 5 main steps are involved in the extraction of metals from the ores. So what is the first step? So first step is your crushing of ores. So first of all, we have to crush the ores. We have to convert it to small pieces. We have to grind it. Okay, so first step involves your crushing of ores. Second step involves concentration of ores. Okay, so as you have crushed the ores, or you can say grinded the ores, converted it to smaller pieces, after that it is eligible for taking it to further process of extraction of metals from it. So second process involves your concentration of ores. Concentration of ores is nothing but your initial purification of ores. Okay, this is known as initial purification of ores, where you remove the impurities which are mixed along with the metals inside the ores from the ore, so that it becomes means useful, or you can say it, so that it becomes worthy to use it in the further process of the extraction of metals from it. So initial purification of ores, or you can say removal of impurities like gangue. Okay, removal of impurities called gangue. So all of you must be knowing this, that the impurities which are present inside the ores along with your metals are known as your gangue or matrix. Okay, so when we remove those gangue or impurities from the ores, initial purification is done. That process is known by the name of concentration, or you can call it dressing of ores. Okay, or you can call it dressing of ores also. Is it clear, everyone? Okay. Third is your conversion of ores. Now we have crushed the ores, finely grinded it. Then we have concentrated it, means we have made it more purified. So by how? By removing the gangue, or you can say impurities, the initial purification of ores by concentrating the ores, that we have done. Now third process is to convert the ores into the metallic oxides. Okay, conversion of ores. Okay, conversion of ores into metal oxides. So this is the third process that we have. So first grinded finely, पूरे अच्छे तरह से उसको टुकड़े टुकड़े कर लिए. फिर जो टुकड़े हमें ओर्स के मिले उसको कॉन्सेंट्रेट कर लिया, उसमें से जितनी गंदगी थी, जितना भी इम्प्योरिटीज था, सबको रिमूव किया बाय कॉन्सेंट्रेटिंग दैट ओर. Third is your conversion of ores into metal oxide. Now why we are converting your ores into metal oxides? Because all of you know this, that your inside the ores, the metals are not only found in the form of their oxides, but they are also found in the form of their carbonates, their sulfides, yes, their means bicarbonates, their halides. Okay, so many forms the metals are found inside the ores. So our main motto is to convert the ores into metal oxides. Why? Because it is easy to extract the metal from its oxide. Okay, it is easier to extract metal from their oxides. That's why we are going to convert your ores into metal oxides. Fourth is your reduction of metal oxides. Okay, reduction of metal oxides. Now how can we reduce your metal oxides? By using common reducing agents such as your carbon monoxide, hydrogen or ammonia. Okay, so we can reduce the metal oxides. How and what we do in this case? We remove the oxygen. Okay, so removal of oxygen takes place and we can get your metal. Now whatever metal we have got in the fourth process, by following all the four processes like crushing, concentration, conversion of ores into metallic oxides, then reduction of metal oxides. So whatever metal we have got in the fourth process, that is not very pure. Okay, we want our metal to be like 99% pure. So how can we do that? By following the fifth step, that is your refining or purification of metal. Okay, refining or purification of metal. This is the last step where we can obtain our means very pure metal which can be utilized further commercially. Okay, clear everyone? Okay, so here you have, I think, understood what are the five main steps that are involved in the extraction of metals from the ores. First is crushing of ores. We have crushed it, grinded it finely. That is also known by the name of pulverization. Converted the ores into small pieces so that we can use it for further processes. Second is concentration of ores. So we will do the initial purification of ore. So whatever impurities or gangue is present inside the ore, we will remove those impurities. Okay, so this is also known by the name of dressing of ores or benefaction of ores. Third is your conversion of ores into metal oxides. अब पहले crush कर लिया, then concentrate कर लिया. अब क्या करना है? We have to convert your ores to metal oxides. Why we are doing it? Because it is easier to extract your metals from the metal oxides than from any other metallic compounds like your metal carbonates or metal sulfides or metal halides. Okay. Now fourth step is to reduce your metal oxides, to remove that is by removing the oxygen. Okay, we can do it by two processes, either by using the common reducing agents like your carbon monoxide, hydrogen and ammonia, or we can use the electrolytic reduction process also for some stable oxides like that of your aluminium. Okay, then fifth is your refining or purification of metals. So whatever metal we have got in the fourth step, that is not very purified. So we will refine it, will purify it by using again different processes, and thus we have obtained our metal and it is used, means it is ready for use in the commercial sectors. Okay. So I hope it is clear to everyone in the class. Yes or no? Chalo. So let's have the processes one by one. Okay. So first is crushing. As I told you, this is not very tough. We are just converting the ores into small pieces by applying some pressure and all. That is also known by the name of pulverization. Second is concentration. Now different ores we have, okay, from which your different metals are extracted. So concentration of ores can be done by, that is the removal of impurities can be done by four different processes. First process is your gravity separation, or you can say hydraulic separation. Okay, gravity separation or hydraulic separation. Second is your magnetic separation. Okay, second is your magnetic separation. Third is your, okay, third I should write here, froth flotation technique. Okay, so third is your froth flotation technique. Okay, and fourth is your chemical method or leaching. Okay, chemical method or leaching. Clear? So these are the four processes by which you can concentrate any ore. So every process that is used during the concentration of ores uses different principles. Okay, अलग-अलग principles use करते हैं हम. कौन से ore को किस मेथड से सेपरेट करना है डिपेंड करता है कि वो ore कौन सा प्रिंसिपल फॉलो कर रहा है. ठीक है, जैसे फॉर एग्जांपल ग्रेविटी सेपरेशन में वी यूज द प्रिंसिपल दैट इज डिफरेंस इन डेंसिटी. Okay, difference in density. So if any ore or impurities has a difference in density, then that ore will be separated from its impurity using your gravity separation. For example, you have some ore where your ores are magnetic in nature but impurities are non-magnetic. In that case, you can use magnetic separation. Okay, froth flotation mein you have such a combination of ore and impurities where either ores or impurities are hydrophobic, that is sticks to the oil particles, and other is hydrophilic, that is stick to the water particle, and those type of ores are concentrated using the froth flotation technique. Chemical method or leaching में what principle we use? We take a chemical solvent and we see that either ore or impurity should be soluble in that chemical solvent and other should be insoluble. In this way, we can use different ores to concentrate using different techniques depending upon what principle is followed by the ores and impurities. Clear? So in this way, we can concentrate different ores. Since these concentration processes are not in your syllabus, so I am not going to explain them in very much detail. If anyone wants to ask me, if anyone is having any doubt in the particular process or wants to know about any particular process, can tell me in the comment section. Otherwise, I will proceed. Okay. Hello Siddhi, welcome to the session. Okay. So, is it clear to everyone? Okay. No Siddhi, you are not too late. Okay, we are just discussing about the different processes of metallurgy. Okay, that's all. Okay. So these are the different processes. Okay, very good. Third is your, after concentrating the ore, what we do? We convert the ores into metallic oxides. Okay, into metal oxides. Now, if you have sulfide ores, okay, or if you have your carbonate ores, how can you convert it to metal oxides? Either by using roasting, or you can use your calcination. Okay, so roasting is used for your sulfide ores. Okay, thank you so much Infinite Gaming. Okay, thank you so much. Chalo, at least one student is there who remembers that today is Women's Day. So thank you so much. So calcination is used for your carbonate ores. Okay, in both the cases your ores are heated strongly to convert them to metal oxides. In case of roasting we use oxygen. In case of calcination we do not use oxygen because carbonate ores already contain oxygen, so we do not need to heat them in presence of oxygen. Okay, so calcination may we always heat the metal ores in absence of oxygen, and in case of roasting we heat the sulfide ores in presence of oxygen. Okay, now after we have converted the metal ores into oxides, fourth process is to reduce the metal oxides, okay, to obtain metals from it. Reduction of metal oxides. Okay, reduction of metal oxides. Now which metal oxides will be reduced by using okay, infinite gaming, no issue. So you can see the see the class of class 9 that I took at 5:15 p.m. Okay, so you can go over there and you can watch all the videos of class 9. It is available in the playlist section also, and you can watch the gas laws also. Today I had taught that the numericals on gas laws from Selena. Okay. So reduction of metal oxides, how we can do this? Reduction of metal oxides can be done in the presence of coke. For example, if you have like cupric oxide and if you react it with carbon, it becomes copper and your carbon monoxide is formed. Okay, so here your carbon is attracting the oxygen and becoming carbon monoxide. So now you can reduce this cupric oxide using your carbon monoxide also, where your cupric oxide becomes copper and your carbon monoxide gets oxidized to form carbon dioxide. Similarly, your cupric oxide can be reduced using the hydrogen also, and it will form your H2O. Clear? So here you can see these all three are acting as your reducing agents. Okay, these all are acting as a reducing agents. So this process can be used for only three metals, like that is copper, lead and iron. Okay, these three reducing agents can reduce only three metals, that is copper, lead and iron. We cannot use the reducing agents like your ammonia, carbon or carbon monoxide or hydrogen to reduce all the metals. Okay, for example, your zinc oxide can only be reduced using the coke. You cannot reduce zinc oxide using your carbon monoxide or using your hydrogen or using your ammonia. Clear? So these are the metals which are reduced by using common reducing agents. Now we have some metals as such whose oxides are very stable. Okay. Yes, Himanshu, I know extraction of aluminium is there in the syllabus. This is not there, but still I am discussing a few part of it, not very in depth. Okay. Just a few part I am discussing over here. Okay, and after this I will go to your aluminium extraction only. Okay. Hello Ariva Mirza, welcome to the session. Okay. Okay. So we have some very stable oxides. For example, your aluminium oxide. This is a very stable oxide. Can we reduce it using these common reducing agents? क्या हम इसे इन reducing agents को use करके reduce कर सकते हैं? The answer is no. You cannot reduce them using the common reducing agent. It has to be reduced using the electrolytic reduction process. Okay, electrolytic reduction process से you can reduce the aluminium oxide because yes, it is very stable in nature. Okay, so oxides of very reactive metals like your aluminium, like your lithium, potassium, barium, calcium, all these cannot be reduced using the common reducing agents. For that you need to use your electrolytic reduction process. Clear? So after we have obtained the metal, what we can do? We have to just refine it, okay, using the electrolytic refining process. Okay, so you can do the refining of metals also by electrolytic refining process, or you can use a distillation process based upon which process will be suitable for which metal to get purified. Clear? So this is the different methods used in the extraction of metals from the ores in the metallurgy process. Okay. Next, we will talk about here extraction of aluminium, which is yes there in our syllabus. So we will be focused on this. So extraction of aluminium, maybe we will discuss all the process of metallurgy one by one. Jitna bhi processes we have read just now, those all processes will be applied during the extraction of aluminium. सारे process को इसको हम लोग यहाँ पे apply करने वाले हैं. So what was the first process? First step, that was crushing of ores. Now before we go on to the process, we need to know from which ore your aluminium is extracted commercially. Which ore is used for commercial extraction of aluminium. ठीक है? So the ore that we use for extraction of aluminium is your bauxite. Bauxite is used and the chemical formula for bauxite is Al2O3.2H2O and its chemical name is hydrated aluminium oxide. Okay? Hydrated aluminium oxide. Now, first step, what has to be the first step? That is grinding of ores. So first step में we will grind your bauxite ore. Okay, bauxite ore को पहले हम यहाँ पर grind करने वाले हैं अच्छी तरह से. Okay, after grinding it, what we can do? Grinding of bauxite ore and heating it. Okay, and what we can do? Al2O3 is also called alumina. Yes, Siddhi, Al2O3 is also known as alumina. Okay, yes. So crushing or you can say grinding, anything, and then heating of bauxite ore. Okay. So after grinding the bauxite ore in a very fine particles, very small particles, what we have to do? We have to heat it. हम इसको heat करेंगे. Okay. इसको क्यों heat कर रहे? Why we are heating the bauxite ore? So that कुछ भी अगर volatile impurities आपके ore में present हो तो वो evaporate कर जाए. Okay. So that volatile impurities gets evaporated. Okay. So this is the first step of your extraction of aluminium. Second step has to be your concentration. Concentration of bauxite हमें यहाँ पर करना है. We have to concentrate the bauxite ore, that is removal of your impurities. Initial process of removal of impurities, that is your purification of ores. Okay. So bauxite ore contains your iron impurities, tin impurities and sand. Okay. Bauxite ores में 3 types of impurities are found: sand, tin and your iron impurities along with the aluminium. Okay. So we want to remove all the impurities by concentrating the ores. हम ore को concentrate करके सारे impurities को remove करने की यहाँ पर कोशिश कर रहे हैं. बॉक्साइट ओर में आपका जो आयरन का impurities होता है, that is very high in amount. So the process that we have to use here to remove the impurities from the ore so that it becomes eligible for the further processes of extraction of aluminium, we have Bayer's process. Okay. So, okay. समृद्धि, bauxite is an ore of aluminium. Bauxite एक ore है aluminium का, from which you can extract aluminium very easily and profitably, and we are studying here the steps of extraction of aluminium from the bauxite ore. Okay. Formula for bauxite I have already written in here. You can see over here. Okay. Now, concentration of bauxite ore is done by your Bayer's process. Okay. Concentration of bauxite ore is done by the Bayer's process because Bayer has designed the every step of this process. So there are 3 steps followed in your Bayer's process to concentrate, that is purify your bauxite ore so that it becomes eligible for the further processes. Okay. So we are using 3 steps. First step is to dissolve. ठीक है, हमें क्या करना है? पहले bauxite ore को NaOH, concentrated NaOH के solution में dissolve करना है. Okay. Bauxite ore in NaOH. So what is the chemical reaction happening here? This is your bauxite ore, Al2O3.2H2O. This is your bauxite ore. यहाँ पर bauxite ore में आपके aluminium के साथ there are so many impurities also. So what we do? We take sodium hydroxide in concentrated form. We put the bauxite ore along with the impurities inside NaOH solution at 140 degrees Celsius and we leave this mixture for 2 to 8 hours. 2 से 8 घंटे के लिए हम इस मिक्सचर को छोड़ देंगे विदाउट एनी डिस्टर्बेंस. सो व्हाट हैपेंस, द एल्यूमिनियम ओर दैट गेट्स डिसॉल्व इनसाइड द NaOH सोल्यूशन. सो आपका एल्यूमिनियम डिसॉल्व हो जाता है and it forms NaAlO2, that is sodium meta-aluminate, okay, जो कि soluble है, okay, and along with that your water is also formed. Okay, so what is the advantage of doing this process? So the impurities, okay, the impurities, that is iron and sand, okay, जो भी impurities आपके bauxite ore में थे, iron and sand, they are insoluble in your concentrated NaOH. okay, ये आपके concentrated NaOH में insoluble होते हैं. तो ये प्रोसेस आपका कोई प्लांट में हो रहा है एट अ वेरी मीन्स लार्ज स्केल. सो व्हाट वी हैव टू डू, वी हैव टू लीव इट फॉर 2 to 8 hours of time. okay, after the aluminum ore has properly dissolved inside the concentrated NaOH solution, we will take this solution of NaAlO2. ठीक है, हम सोडियम मेटा एल्यूमिनेट के सोल्यूशन को लेंगे और उसको फिल्टर करते हैं. ठीक है, फिल्टर द मिक्सचर. क्यों फिल्टर कर रहे हैं? सो दैट की इम्प्योरिटीज जो है वो आपके फिल्टर पेपर पे रह जाए और आपका जो एल्यूमिनियम है जो कि NaOH में डिसॉल्व हो चुका है, एल्यूमिनियम का ऑक्साइड, वो आपका फिल्ट्रेट के साथ जो है फिल्टर पेपर को पास कर जाए और हमें सोल्यूशन के फॉर्म में मिल जाए. इस तरह से दिस वे हम उस इम्प्योरिटीज जो कि आयरन एंड सैंड की इम्प्योरिटीज है उसको हम बॉक्साइट के ओर से रिमूव कर पाते हैं. ओके, सो दिस वे वी आर रिमूविंग द इम्प्योरिटीज from the bauxite ore. How? By dissolving your ores inside your NaOH solution, and your impurities are insoluble, so they will come out as precipitate and it will come out as residue on the filter paper. Okay, now second step में क्या होता है? What is the second step that we are using over here? So second step में we do dilution. Okay, dilution or hydrolysis of सोडियम मेटा एल्यूमिनेट एट 50 डिग्री सेल्सियस. ठीक है, सो हम अब सेकेंड स्टेप में वी आर डूइंग द डाइल्यूशन और यू कैन से हाइड्रोलिसिस ऑफ सोडियम मेटा एल्यूमिनेट एट 50 डिग्री सेल्सियस. सो व्हाट हैपेंस, यू टेक सोडियम मेटा एल्यूमिनेट, you take water and react them at 50 degree Celsius. What happens? Your sodium hydroxide is formed and your aluminium hydroxide is also formed, which is obtained as a precipitate. Okay, this NaOH is reused in the first step. Okay, this is reused in the first step. Clear? And after from here we take out this aluminium hydroxide. So aluminium hydroxide हमारा कैसे present है यहाँ पे? Precipitate के form में. So we can take it out. What we will do? Again इस solution को filter करेंगे और चूंकि आपका aluminium hydroxide एक precipitate है, so ये आपका filter paper पे as a residue collect हो जाएगा. After we have collected your aluminium hydroxide, we will wash it and then dry it to remove all the impurities. Okay, we will wash your aluminium hydroxide, again dry it. We will follow this step 2 to 3 times to remove every impurities that is present inside aluminium hydroxide. Clear? Now third step. Third step में क्या करना है? We will ignite. Okay, we will ignite your aluminium hydroxide. So हम आपके aluminium hydroxide को यहाँ पर ignite करने वाले हैं, यानी कि आग लगाने वाले हैं at 1000 degree Celsius to thermally decompose it. Okay, we will do its thermal decomposition to thermally decompose it. Okay, so AlOH whole thrice है, इसको हम लोगों ने 1000 डिग्री सेल्सियस पे इग्नाइट किया. What happens? It will undergo thermal decomposition to produce your aluminium oxide and your water. This aluminium oxide is known as alumina. Okay, these three processes are used in your Bayer's process to concentrate the bauxite ore and obtain alumina from bauxite ore. Okay, so you must be questioning yourself, or you can question me also, that ma'am, the formula for bauxite ore is Al2O3.2H2O. Here also by following all the 3 steps of Bayer's process, we are obtaining alumina only. Okay, so can't we just heat your bauxite ore and obtain your alumina from it by removing the water vapor or moisture from it? So it's not the proper way to get alumina. Because in Bayer's process, we are also removing the iron impurities that was present along with your aluminium oxide inside the bauxite ore. Simply heating it, अगर सिर्फ इसको आपने simply heat कर दिया, so impurities will not be removed. Impurities remove नहीं होंगे. Okay. So our main motto, हमारा main मकसद जो है, वो यहाँ पे solve नहीं होने वाला. If we are simply heating your bauxite ore. So for that process, we need to follow all these 3 steps of your concentrating the ore. Clear? Now, in the second step only, in the concentration process only, we are obtaining the metal oxides. Okay. So third step जो metallurgy का है, conversion of metal ores to your metal oxide, that will be skipped here. Okay. इसको यहाँ पे skip करना पड़ेगा because we do not need to do any roasting or your calcination because we already obtained your aluminium oxide in the second process, that is your concentration of bauxite ore. Okay. Now we have got your aluminium oxide and our aim is to extract aluminium from it. हमारा मकसद है इसमें से अब aluminium को extract कर देना. Okay. So as you all know, your aluminium oxide is a very stable oxide. ठीक है, ये एक बहुत ही ज़्यादा stable oxide है. So if you are thinking that you react aluminium oxide, no voice. Are you sure, Ramesh Alam, that no voice is there? Just no voice. Okay. So it's perfectly all right. I doubt you have a problem in your system. So please check that. So aluminium oxide is a very stable oxide. And if you think that aluminium oxide ko, if you are trying to reduce it using carbon, or you can say if you are trying to reduce your aluminium oxide using carbon monoxide, or you are trying to reduce your aluminium oxide using hydrogen. So this reaction, if you are thinking that this reaction will take place over here, so you are absolutely wrong. Nothing of this sort is going to happen. ऐसा कुछ नहीं होने वाला है. Okay, because aluminium cannot be reduced using some common reducing agent. Okay. And because of that only, aluminium was a very costly metal like gold and silver in the early days, whereas your aluminium is the most abundant metal, but still it was very costly. Okay. Now the solution of this problem was given by your Hall-Héroult. Okay. So before proceeding to the Hall-Héroult process, let us understand what were the problems faced by people during the electrolytic reduction of your alumina. Okay. So if you are trying to do the electrolytic reduction of alumina, so during the electrolytic reduction of alumina, all of you know this, that if you have to do the electrolysis of any metal or any compound, you need to have that compound in the molten form, yes or no, so that to conduct electricity. So during the electrolytic reduction of alumina, 2 major problems were faced. Okay. 2 major problems were faced in this case. What were the problems? Okay. What were the problems? So during electrolysis, as I told you, हमें electrolyte को molten state में रखना होता है. So when people tried to melt your alumina, it was melting at 2050 degrees Celsius. Okay. So first problem was that melting point of alumina was 2050 degrees Celsius. ठीक है, 2050 डिग्री था. एंड इस टेम्परेचर पे क्या हो रहा था कि आपका जो एल्यूमिनियम है वो वेपराइज हो जा रहा था. ओके. एंड एट दिस टेम्परेचर व्हाट वाज हैपनिंग, योर एल्यूमिना was getting vaporized, your aluminium was getting vaporized, and this temperature aluminium was getting vaporized. Okay. So vaporize हो जा रहा था. फर्स्ट मेजर प्रॉब्लम ये था. सेकेंड मेजर प्रॉब्लम था कि एल्यूमिना जो होता है, Al2O3 जो होता है, ये काफी बैड कंडक्टर है इलेक्ट्रिसिटी का. ओके, काफी बैड कंडक्टर है इलेक्ट्रिसिटी का. सो इट एक्ट्स एज अ नॉन इलेक्ट्रोलाइट. ओके, सो इट एक्ट्स एज अ नॉन इलेक्ट्रोलाइट. क्लियर? So these were the 2 major problems faced by people during the electrolytic reduction of alumina. Okay. Now the solution to this problem was given by Hall and Héroult. Okay. So what Hall and Héroult suggested? So Hall and Héroult suggested to overcome this problem. So the problem that were faced by the people, to overcome those problems, Hall Herold suggested that first is to add two compounds to alumina during its electrolytic reduction. Okay, so alumina का electrolytic reduction करते time you have to add two compounds to alumina. Okay, so that its electrolytic reduction can be made possible. Okay, what were those two compounds? Those two compounds, first was your cryolite, NaAlF6. So cryolite was told to be mixed with your alumina, okay, during its electrolytic reduction. Clear? Now, first purpose that your that your cryolite was solving, or you can say serving, okay. तो इसका first purpose, first function क्या है? It lowers the melting point. Okay, it lowers the melting point. ये melting point को low कर रहा था, कम कर रहा था. Okay, it lowers the melting point of alumina from 2050 degrees Celsius to 950 degrees Celsius. Just imagine 2050 से सीधा 950. So this is a very huge reduction in the melting point of alumina, and 950 पे your aluminium will not vaporize also. Yes, this is the first major function served by your cryolite. Second function was that it increases, okay. Second function that it was serving was that it was increasing the conductivity also. Okay, it also increases the conductivity. Your cryolite was also increasing the conductivity, as it is a very good electrolyte. Okay, as it is a very good electrolyte. Clear? So ये आपका conductivity भी increase कर रहा था because it was a very good electrolyte. So this was the first compound added to your electrolytic reduction of alumina. Second was your calcium fluoride, that was known as your fluorospar. So what was the function of this one? It also increases the conductivity. Okay, it was also increasing the conductivity because your calcium fluoride is made up of your calcium and fluoride ion, and both of these are very small ions, so they can conduct electricity very fast, as they can travel very fast. Okay, second purpose that it was solving was it acts as a solvent. Okay, this was acting as a solvent, okay, so that your alumina can get mixed thoroughly in the fluorospar and other your other electrolytes. Okay, so before okay, so everyone who are present in the class can tell me if you are getting everything or not, so that I can know. Also, if you're really liking it, so do not forget to share it with your friends and like the class. Okay, so tell me fast if it is clear to everyone or not. Okay, okay. So is it clear to everyone? Okay, just let me drink some water. So I hope it is clear to everyone in the class. Hello Anubhav, welcome to the session. So this is the second one which is added to your alumina during its electrolytic reduction. Let's talk about the Hall Herold process. Hall Herold process of electrolytic reduction of alumina. electrolytic reduction of alumina. Okay. So what we do here, the electrolytes that are taken here is, first is your alumina, second is your cryolite, third is your calcium fluoride. These are the three electrolytes which we take during the Hall-Héroult process of electrolytic reduction of alumina. Okay, and what is the ratio we are taking here? 1:3:1 by weight. Okay, why we are taking more of your sodium aluminum hexafluoride? Because this is acting as a very good conductor. Also, this is reducing the melting point of alumina from 2050 degrees Celsius to 950 degrees Celsius. Because of this reason, we are using your cryolite in more weight. Okay, we are using it in more amount. Now let's talk about the cell where your electrolytic reduction of alumina will take place. So this is the cell, this is the construction of cell that I am doing here. Try to understand it. This cell has a sloping bottom. Okay, this cell has a sloping bottom so that whatever molten aluminium is formed can get accumulated over here and can be tapped out through this tapping. Okay, so this sloping bottom is used to collect your molten aluminium and to tap out from this tapping. Okay, next we have your graphite electrodes. Okay, that is made up of carbon. So we have the fused electrode, that is your anode, which is hanging over here. You can see this is your positive part, anode, and entire cell is fixed with the carbon lining. Okay, entire cell is fixed with the carbon lining that we have, and this carbon lining is acting as your cathode. Okay, this carbon lining is acting as your cathode. Clear? This is your cathode, this is your anode. Now this is the molten electrolyte that we have. Three compounds are present as electrolyte. First is your alumina, second is your cryolite, third is your fluorspar. Above this molten electrolyte we have powdered coke. Okay, so this is the powdered coke we have. Okay, this is the sloping bottom we have, and beneath it what we are doing, we are heating this. Okay, what we are doing, we are heating this electrolyte so that it can get into molten form, ताकि इसको हम molten form में convert कर सके. Okay, now why we are using powdered coke? क्यों powdered coke use किया जा रहा है यहाँ पर? So the reason for using powdered coke is, so powdered coke is used to prevent, this is the first function that your powdered coke is serving over here. Okay, so powdered coke is used to prevent the loss of heat. Okay, it is used to prevent the loss of heat from the electrolytes due to radiation. Okay, so radiation के वजह से होने वाले heat loss को आपका powdered coke जो है वो prevent करता है. Okay, powdered coke is used to prevent the loss of heat from the electrolytes due to radiation. Okay, so this is the first purpose that is served over here by powdered coke. Okay, yes Vidushi, and to prevent burning of anode. Yes, absolutely correct. That to prevent the burning of anode also we are using your powdered coke. Okay, so that we will study later. So now let's understand four terms. First is your pav, not pav bhaji but pav. Okay, so you can remember it in that way. So positive anode oxidation. Okay, second is your oil. That is oxidation is loss of electron. Clear? Then we have your NCR, that is negative cathode reduction. Yes. And your rig, that is your reduction is gain of electrons. So you have to understand these terms. Next, so let's talk about the types of ions present inside the electrolyte. Okay, so electrolyte में कितने तरह के ions हमारे present हैं? Okay, yes. So first is, let's talk about alumina. So alumina say you have your aluminium ion and you have your oxide ion. Okay, so oxide हमारे पास है, aluminium है. Then cryolite say what we are getting? We are getting your sodium ion, we are getting your aluminium ion, and we are getting your fluoride ion. Okay. Then CaF2 fluorospars हमारे पास क्या क्या है? Ca2 plus है और F minus है. Okay. That is, we have 3 cations, okay, inside the electrolyte, and we have 2 anions inside the electrolyte. ठीक है. So all of you know this, that your cations go to cathode in the electrolytic reduction or electrolysis, and anions go to anode. Why? Because cathode is negatively charged, anode is positively charged. So ये तीनों cation कहाँ जाना चाहेंगे? At cathode. लेकिन क्या तीनों कैथोड पे पहुंच के खुद को डिस्चार्ज कर पाएंगे? Will they be able to discharge themselves after reaching the cathode every cation? So the answer is no. Every cation will not get discharged. सारे cations का यहाँ पे discharge नहीं होगा कैथोड पे. Only that cation will get discharged which comes in the lower position in the reactivity series. Okay? Yes. So preferential discharge. Yes, Vidushi, very good. So all the 3 cations will go to cathode, but only one of them will get discharged. सिर्फ उनमें से एक ही discharge होगा और वो है aluminium. क्यों? क्योंकि aluminium का यहाँ पे electrolytic reduction हो रहा है इसलिए. तो आंसर है नहीं. That is not the reason. But because your aluminium comes below sodium and calcium in the reactivity series. ठीक है. रिएक्टिविटी सीरीज में आपका एल्यूमिनियम जो है वो सोडियम और कैल्शियम के नीचे आता है, बिलो आता है. That's why aluminium will get discharged first. Okay. So the metal which is less in the reactivity series or low in the reactivity series gets discharged first. ये आपका preferential order of discharging है. Okay. So aluminium will go to your cathode. It has 3 positive charge, and to discharge itself it can take 3 electrons from the cathode and will become your molten aluminium. Okay. Molten aluminium. Clear? So this is the first reaction that is happening at your cathode, and what is happening? Your reduction. Your aluminium ion is getting reduced, reduction of Al3 plus to give your molten aluminium. Okay, clear everyone? So this molten aluminium will get deposited on the sloping bottom because this carbon lining is your cathode. Yes or no? And if your aluminium is formed at cathode, so this molten aluminium will get deposited over this sloping bottom and will be tapped out using this tapping. Clear? So cathode पे ऐसा हुआ. अब एनोड पे क्या होगा? यहाँ पर एनोड पे भी जाने वाले 2 आयन्स है हमारे पास. एक आपका ऑक्साइड आयन है and second is your fluoride ion. Okay. So now which will get discharged first? So please remember यहाँ पे भी आपका एक सीरीज फॉलो होगा जिसमें आपका in the series, please remember this, in the series your oxides are lower than fluorides. Okay, oxides are lower than fluorides. So oxides will get first discharged at their anode and fluorides will remain in the solution. They will not get discharged. Yes, electronegative series. So here your oxygen has to lose 2 electrons to become oxygen atom. This is not stable. ये stable नहीं है. This is not stable. So it will combine with one more atom to give your oxygen gas that is formed at anode. Now one thing you have to understand, that during your oxidation and reduction process, your number of electrons lost should be equals to number of electrons gained. ठीक है. यहाँ पर देख लो आप 2 इलेक्ट्रॉन लॉस हो रहे हैं, यहाँ पे 3 इलेक्ट्रॉन गेन हो रहा है. ओके. सो व्हाट वी कैन डू, वी कैन बैलेंस दिस नंबर ऑफ इलेक्ट्रॉन्स. हाउ? बाय पुटिंग 4 over here. if we put 4 over here, then your 4 ions of aluminium has to gain 12 electrons, and then 4 moles of aluminium will be formed, which will be produced as molten aluminium. Here 12 electron आपका gain हो रहा है, so 12 electrons has to be lost also. So 12 electrons loss अगर होना है, so how many oxygen ions should be there? 6, because 6 oxygen ions जो है वो 12 electrons loss कर सकते हैं, and these 6 oxygen atoms will be formed. So 3 oxygen and 3 oxygen will combine together to give 3 moles of your oxygen gas, which is formed at anode. This way you can balance the reaction or balance the number of electrons lost or gained. Now here comes the second function of your powdered coke. So you can see over here that your oxygen gas is formed at anode. Oxygen is formed at anode. So what happens कि आपका anode जो है वो तो graphite से बना है, and graphite is what? Graphite is nothing but your carbon. Okay? So जो oxygen आपका anode पे बनता है वो आपके anode के carbon के साथ react करेगा and it will form your carbon dioxide, which will escape into the atmosphere in the form of gas. Yes, it is a gas, so it will escape into the atmosphere. Now, this reaction is highly exothermic. ठीक है, this reaction is highly exothermic. So ये इतना exothermic होता है कि if your oxygen is going and attacking the carbon of the anode can catch fire. The reaction is so exothermic. Yes. So due to its exothermic nature, your anode can catch fire. ठीक है, anode आपका आग पकड़ सकता है. So to prevent this catching of fire by the anode, what we do, your powdered coke is used. So powdered coke, what it does, it increases the surface area for oxygen to react. Okay, it increases the surface area. Basically what it's doing, it increasing the surface area for oxygen to, okay, for oxygen to react. Clear? So powdered coke क्या कर रहा है? Surface area को बढ़ा दे रहा है. Because powdered coke is also carbon only. Now oxygen is getting more options to get react. That is with the powdered coke also and anode also. So anode के साथ उसका reaction इतना intense नहीं होगा and now your anode will not catch fire. So powdered coke is increasing the surface area for your oxygen to react, due to which your anode is not catching fire. Clear? So this way your powdered coke is preventing the anode from catching fire. Next, as you can see that oxygen gas is evolved at anode. Now the carbon at anode reacts with this oxygen gas to form your carbon dioxide, which escapes or you can say vaporizes in the atmosphere. Due to this, your anode decreases slowly. Okay. So धीरे धीरे जितना भी कार्बन है एनोड का वो ऑक्सीजन के साथ रिएक्ट करके ऑक्सीडाइज होता जा रहा है और कार्बन डाइऑक्साइड के फॉर्म में एनोड से बाहर निकलता जा रहा है. So धीरे धीरे what happens, slowly what happens, your anode decreases in size, due to which your anode needs to get replaced. Okay, anode needs to get replaced from time to time. Get replaced from time to time. Clear? So this is the whole Hall Heroult process, and here with this we come to the end of this session. So is everything clear to everyone in the class? Please let me know once. ठीक है? So anode will decrease in size and that's why your anode needs to get replaced from time to time. Clear? So this is whole Hall Heroult process, and with this we come to the end of this session. So I hope everyone liked this session, though there was a little negativity in the starting of this session. So that was not able to overcome our spirit of learning the things. So I hope everyone liked the session. So those who are in class 10, okay, for them the batch has already started on Plus platform, and those who are in class 9 and moving to class 10, yes, Vitushi, you have a refining process also. that is hoops electrolytic refining. Okay, that I will cover in the next class. Okay, hoops electrolytic refining process I will be covering in our next class. Okay, so if you are in class 9 and moving to class 10, you can enroll in this batch, that is champions batch, starting from 16th of March using my code Manisha Live. And if you are not sure about enrolling in the plus batches, the thing you can do is that download the Unacademy app, use my code Manisha Live, unlock all the special classes and just watch them. Okay, enjoy the special classes, and once you are sure about taking the subscription, do go for it. Okay, so Unacademy is there with you in every step of your success, so do not miss this chance. So you can just watch the special classes which are absolutely for free. Clear? So this was all for today's session. So thank you everyone for watching this session, and let's meet tomorrow again at 9 p.m. for class 10 session. So bye everyone. Thank you so much. Take care. Good night and all the best for your upcoming exams.